Okay, it's 5 p.m. Hello, people.
Hey, how's it going?
Good. So, yes, so I posted today's lecture notes on the canvas. It's section 8A and 8B. Do you guys see that? Okay, great. So if you read ahead of time, you will see there are many two topics in today's class. The two topics is not as listed as the title. The title says linear and exponential growth. However, the two topics I really want to talk about is first, living in Montana. Second, please second, bacteria growth. Okay, so that's the two topics I really want to talk about. And the underlying methodology is kind of linear and exponential growth. However, when we want to talk about a topic, we have to have a first-hand experience about the topic. So in order for you guys to have a first-hand experience of small town Montana, I found this YouTube video on this topic, living in Montana. Okay, so we are going to watch this YouTube video for like 7 minutes. Okay, I hope that's a good introduction. We're going to watch it for maybe 16 minutes is enough. Okay, so you guys see my screen?
Yes.
Yeah, great. Best places to live in Montana in 2021. Okay, this is the video we're going to watch. We're going to watch it for 6 minutes. Okay, so the total video is 10 minutes. So I think we don't need to watch every town this video talks about. I think watching for 6 minutes gives us a pretty good sense of today's topic. Okay.
We can't afford to not be paying.
Okay, first of all, this is advertisement. This is not the video yet. Let me skip this advertisement.
Attention to what's happening in other parts of the world.
The mission of the Colorado Springs World Tourism Council is to educate and engage.
Are you planning to move and start a new kind of life? Do you have any places in mind? Is scenery, opportunities for outdoor activities, source of income, and local people your basis in choosing one? If your answer is yes, Montana is what you're looking for. So continue watching, because in this video, we will discover the best places to live in Montana. But before we get into it, please do me a favor by clicking the like and subscribe button, and do not forget to turn on the notification bell so that you'll be notified anytime we release a new video. Montana, also known as Big Sky Country, is located in Jefferson County, famous because of its blue skies, crystal streams, and forests with wildlife. It is one of the least populated states in the United States of America, and is widely known for its natural beauty that attracts many people to live and settle there for good. In addition, many people say Montana is the best place to live in the U.S. because it has unique cities that are resided by friendly people, and it also has affordable kinds of living. With that, grab your snacks, sit back, and relax, because here are the best places to live in Montana. Number 10, Bozeman. Are you an outgoing or adventurous person? If yes, then Bozeman is perfect for you. Bozeman is well known for its variety of outdoor activities like kayaking, skiing, fishing, and mountain climbing. It is located with aesthetic Rocky Mountains at the intersection of 90 and Highway 191. In addition, it also has the best public schools that are conducive to learning, plus a friendly and healthy community. However, since Bozeman is considered the fourth largest city in Montana and known for its fastest growing rate, living here can be a bit pricier. Moreover, the expenses will be worth it, because of its unique geography, fun and exciting activities that you can do together with your family or loved ones. Number 9, Helena. Next up, Helena. It is the capital of Montana, USA, which is the top 2 among the most recommended places to live in the said country regarding its livability, cost of living, and education. Aside from that, Helena is a suburban city, which means that it consists mainly of residential areas and has a lower population than urban places. Moreover, living there will make you one step away from top-rated attractions like parks, museums, and many more. Some of the best sites to visit are Mount Helena City Park, an excellent place to walk with your pets and romantic dates while enjoying a good view. The second is Centennial Park, a good space for you, your family, and your friends. You can enjoy skateboarding, rollerblading, and exercising in a simulated rock boulder. Number 8, Missoula. Third on the list is Missoula. It is the second largest city in Montana. Since it is located near the University of Montana, that is also considered home, it is not questionable why many college students and families attract and live there for good. Moreover, it is famous for its blue ribbon trout fishing. And if you're that person who loves beer, then Missoula, which has a growing collection of beer breweries, is for you. In addition, Missoula also has a high quality of life in the healthcare system and high-ranking schools. In addition, summer in Missoula is good. However, it will be a little bit depressing during winter because it is prone to inversions that keep it cloudy and cold. So if you plan to live there, be ready for that. Number 7, Kalispell. Kalispell is a small town kind of city, but it is a great place to live. Moreover, Kalispell has a naturally beautiful landscape and friendly residents. However, if you think that living in a small town is boring and odd, it's not the case with Kalispell because it can offer you exciting things to do. You can enjoy many outdoor activities with your loved ones like biking, hiking, skiing, and more. On the other hand, housing in Kalispell can cost you a fortune, and it is one of the cons of moving there. However, it will be worth it since healthcare and transportation are cheap, and the most interesting one is there's no sales tax, which means you can enjoy shopping without worrying about tax. Number 6, Livingston. Next on our list is Livingston. If you want to live in a place where you can assure your family's safety, Livingston is for you. It has a low crime rate and is one of the safest cities in Montana. Livingston is a neighboring town of Bozeman. However, it is a town entirely on its own because it also has a unique history, vibrant community, and independent businesses. In addition, this city is also familiar to families since it is considered a kid-friendly city and it has a quality school system from kindergarten to higher education. Moreover, if you also love the nightlife, Livingston has plenty of cozy bars to have a blast and where you can watch live music performances. One thing that you should remember if you will live in Livingston is the relentless wind. You see, Livingston is also called Montana's windiest city, so you have to be okay with it. Number 5, Four Corners. Another best place to live on our list is Four Corners, Montana, located in Gallatin County. If you're married with kids or are planning to build a family, living in Four Corners is a great choice, given that it is number 1 in the best places to raise a family in Montana. In addition to that, Four Corners is a relatively small town, and most of the residents here own their own homes. Most of all, Four Corners also has a low crime rate so that you can ensure your safety, and most of all, living here is less expensive than in the US. Number 4, Whitefish. We are down to the number 8 on our list, the Whitefish. Whitefish, Montana offers all types of exciting things to see and do. It is located in the Rocky Mountains of northwest Montana, and just like Four Corners, it also has a relatively small population. As I previously mentioned, Whitefish has many things to offer that attract tourists, so many people come in.
Data science and analytics.
Okay, perfect timing for the advertisement. Yeah. Okay, so we're done with the video. So I want to ask you guys, how do you guys feel after you watch this video, do you want to move to Montana? Type yes in the chat if you want. Type no if you don't want. Okay? I'll type no. What? Why everybody is typing no? This video is very exciting. Okay. So, okay. So, do anybody want to share their opinions about Montana? Why you don't want to move to Montana? Sharing. Feel free to share. This is not a math class. This is a kind of math for life class. So I'm encouraging you guys to voice your opinion. Yeah, feel free to speak out. Speak out, please. Hey, Dasha, I see you typing in something. Would you want to say? Hey, Dasha.
I said that it's super boring. It's literally in the middle of nowhere. I wouldn't want to live there, honestly.
Okay, great. Thank you for sharing. Hi, Roche. You said you love Colorado, but did you ever live in Montana before?
No, I don't want to either.
Okay, cool. Okay, so it surprised me that the video is really well made, and even after watching this video, nobody want to move to Montana. No wonder the housing price in Denver is skyrocketing. Everybody want to move here, move to Denver, not moving to Montana. Okay, that's so much joke. Okay, so let me remind you guys, this is a math for life class. So we're just talking some methodology in a life context. Okay, so in the future, if I ask any question like this, please be encouraged to share your voice, your opinion. Okay, and do not treat me as a professor. I'm not a professor. I'm just a teaching assistant. So my job is communicate with you, help you. Okay, not have only any kind of suppression of your freedom of speech. Okay. So that's so much talking about living in Montana. So let's do some math related with that topic. Okay, so this topic of today's class is so-called linear and exponential growth. So what are the difference between the two types of growth? As explained here, linear growth, when an quality grows by the same absolute amount in each unit of time. So if you look at this blue line, this is linear growth. So for every turn, the population increase the same amount. Okay, so it's linear, same amount. The second type of growth is exponential growth. Exponential growth occurs when quantity grows by the same relative amount, that is same percentage. So this is exactly the same idea with the compounding interest. Every time you are compounding the same percentage, however, your principal is growing. So each time you are adding a little bit, the growth accelerates. Look at this red line. So look at it increases kind of slowly, then it's increasing faster, then increasing faster and faster. Okay, so this is the exponential growth. So the blue line, a picture was a silent words. So when you read those sentences, if you feel confused, please watch this picture again and again, okay? To have the better understanding. Does anyone has any kind of question about understanding of those two concepts? Okay, cool. So according to the polling of our class, this question does not make any sense in the social context, because none of the people in our class want to move Montana. If nobody want to move there, how is the population still growing? Okay, so let's say there's many antisocial people. In order to make this question true, so you have to imagine there are a lot of anti-society people, anti-social people, who just like to live in the place of nowhere, in the middle of nowhere. Okay, they are moving to town A and town B in Montana. Both towns, starting with the population of thousands. Look, just 1,000 people in the town. I would bet you can easily know 1/3 of the population of the town easily if you go to the bars very often. So the town A growing 50 people each year, and town B increase 5% each year. Okay, so what type of the growth exhibited in the two towns? So this is just a question ask you about your understanding of the concept. You have to understand what is linear growth. So the same absolute amount, the keyword is here. Look at town A, exactly 50 people every year. So this fits into the category of the same absolute amount. So town A, linear growth. Similarly, if you look at how the town B's population is growing, so it grows 5% per year, which means same relative amount, not the same percentage. So this fits into the category of exponential growth. Okay. So how about the population of the 1 year? Town A, just a sound out of 50 people, right? Town B, 1,000 plus how many people? 5% of 1,000, right? You can also write like how you grow your money in the bank. So 1 plus 5%. So if we do the calculation, it's exactly the same amount. However, the issue is that each year it grows 5%. 5% of the principal value. Okay, so just imagine this is your principal money in the bank. But this principal is also growing. So how would the population be after 10 years? So let's make a table. After 10 years, so each year you add 50 people to the first town. 10 years, you add 10, 50 people to the first town, right? So you are adding ten times. So you're adding 500 people. Okay. So after 10 years, the first town still have 1500s. How about the town B? You start from a sound, then each year you grow your 5%. You times 5% to this, times each time you times 1 plus 5% is the next year's population. How many 1 plus 5% we have? 10, right? They are all times to the value. Okay, so together you have 1 plus 5% to the 10th power. Okay. Does anyone have any question why this is true? Why the 10%, 10 times power is here? Any question? Okay, so we need some diligent people help me to do the calculation. I want somebody to help me to figure out what is this number here. Thank you, Elizabeth. It's 1,629 people. Okay. So which town is growing faster? Just look at the population. Obviously town B, right? Town B has more than 1,600 people. So we conclude town B grows faster. That's it for this question. Okay, so does anyone has any question before we turn to the next page? Okay, so example 2 is very similar with this question. With example A, part A, it just asks you what type it is about the growth. So I'm not going to tell you the answer right now. Instead, I want you to think about it. Example 3 is also an interesting question. Actually, I heard this story like 15 years ago when I was in high school. Okay, so instead of me talking the whole class, I want to give you 1 minute to think about example 2 and 5 minutes to work on example 3. Okay, so don't worry if you cannot get it, we will come back together to discuss it. Okay, so spend 6 minutes to work on those 2 questions. Feel free to ask me any question. Okay, 6 minutes is over. So let's look at example 2. You have invested money in a bank account earns 1.25% compound monthly. So look at how the money is growing. Each time it's growing 1.25%, right? I mean, it is compounded monthly. So each time is this number divided by 12 is how much the growth is, right? So this fits into the category of exponential growth. Okay, that's it. Any question about this one? Okay, so let's look at example 3. When chess was invented in the ancient times, a king was so enchanted that he said to the inventor, "Name your reward." By the way, do you guys know where the chess is invented?
No.
Okay, so when I in high school, when they were talking about this question, they specifically mentioned that chess was invented in India. Okay, so this story happened in India. So if you please, king put 1 grain on wheat, and on the first square of the chessboard, second grains on the third square, 8 grains on the fourth square, and so on and so on. The king gladly agreed, thinking that a man is a fool, asking for a few grains of wheat when he could not have had gold or jewelries. Okay? When the inventor come back for the reward, the king had him beheaded. That's so cruel. This is tyranny. Beheaded. Why? So let's calculate how much grains this person get. Okay. So the first square has 1 grain. Second square has 2 grains. Okay. But how these 2 is come from? Coming from 1 times 2, right? The third square, how many grains? 4 grains. How these grains coming, 4 grains are come from? It's 1.2.2, or times 2 times 2, right? You are times 2 to the previous number of grains. How about the fourth grain? Fourth square. So very similarly, you are times 2 again. So what is the trick here? Look at the 2 to the 0 is the trick. So each time you times 2 to the number. So this is 2 to the 1, right? You times 2 to it. This is 2 to the 2. This is 2 to the 3. So each time the number of grains is 2 to 1 additional power. The 5th time, I don't want to be bothered to write it out. So it's 2 to the 4th. How about the last square? 64 square. So I cannot write explicitly, but you see that for each square, you have the power which is 1 unit less than the square. Okay, so here the square number is 5. You have 2 to the 4. So here the square number is 4. You have 2 to the 3. So each time you're 2 to the power 1 unit less than the power. So here is 64. So it should be 263. So you're just repeating times 2 again and again to it. Okay, so that's how we figure out how many grains on those squares. But the issue is that we also need to calculate how many total grains we want. The first square, you only have 1, which is 2 to the 1 minus 1. How about the second? It's 1 plus 2. Okay, so you have 3. How much? 1 plus 2 is 3. So what does it mean? 3 is 4 minus 1, right? Do you see the pattern? Okay. Or in other words, it's 2 to the 2 minus 1. Okay. So look, what do you have here? As we write more and more numbers in the blank space, you will see the pattern. How about the third square? So it's 4 plus 2 plus 1. Okay, all the grains you have in the previous squares, including this square. 7. How much is 7? 8 minus 1, right? So 2 to the third power minus 1. Okay. So now the pattern is kind of getting more clear. Each time is 2 to the power minus 1. And each time you are increasing the power. So why this is true? So this time, I'm going to show you on the fourth square why this power is always true. So how about the fourth square? You have 2 to the 3, right? Plus 2 to the 2 plus 2 to the 1 plus 2 to the 0, right? This is the total number of grains you have. But this time, instead of calculating directly, I add a 0. I add a trick 0. This is total number of grains. I add a 0 by adding a 2 to the 0 minus 2 to the 0. Okay, so this is a new 0 I added. So this is 1 minus 1, right? Everything looks very easy. So if you copy your calculation, so this minus 2 to the 0 and minus 1 here, then you can combine all the terms before it. 2 to the 0 is 1 plus 2 to the 0. So this becomes 2 to the 1, right? Just for this part. Right? 2 times 2 to the 0 give you 2 to the 1. Does anyone has any concern why this is true? So this is the chain effect. So then this 2 to the 1 can add with the previous 2 to the 1. You got a 2 to the 2 here, right? Then this 2 to the 2 can add with the previous 2 to the 2, got a 2 to the 3. Then this 2 to the 3 you eventually get can be added to the previous 2 to the 3, which eventually gives you 2 to the 4. Okay, so I'm running out of space here. Let me write on the opposite side of the paper why this is true. So this is the trick I added. This is just 0, does not affect anything. Okay, then I'll be able to combine terms together. Those two terms, since they are identical, they are added, means they add, this becomes 2 times 2 to the 0. So this addition become 2 to the 3 plus 2 to the 2 plus 2 to the 1 plus 2 times 2 to the 0 to the 1, right? So you are still minusing this 1. Okay, this is where it is from. You're combining those two. So the next step, you are combining those two. Those two. So since they are identical, when the two identical numbers are added to each other, it's just 2 times itself. Keep this -1 still there. Okay, so this is 2 to the 2 plus 2 to the 2. Okay, so you see we successfully merge the two items. Then we have another chance to merge the two items again, since we have some identical stuff. You see, this is kind of chain effect. So 2 times 2 to the 2 is 2 to the 3. Great. This will be identical with the first term again. So you have 2 times 2 to the 3. 2 times 2 to the 3 is just 2 to the 4. Okay, that's it. So each time you're merging the identical terms. So no matter how big your number is, every time you're creating an identical term with your number. So you keep merging and merging until you get the final term. And the final term is always 1 power higher than the highest term. Okay, because the last number you created by such a trick, it will be always the same with the largest number you have here. Okay. So I showed how the calculation is done. Does anyone has any question? So assume you do not have any question. So we use exactly the same trick. This is 2 to the 4th minus 1. Okay, we rotated the number already. So for the 5th square, it's going to be 2 to the 5th minus 1. Okay, just repeat this almost exact same calculation. And you know that the last step, after you add the last step, you will get the power, which is the same with the square numbers. Okay, previously you have 1 degree less than the square. Since you are always creating an identical copy, now 2 times the previous number, make it 1 degree or 1 power higher. So now the 2 to the 4 has been upgraded to 2 to the 5th. Okay. So this is just 2 to the 4 minus 1. We just copy what we write down, 2 to the 5th minus 1. So just repeat it. I'm super lazy. I don't want to calculate or to do the same calculation again, but I see the pattern already. Okay. So this is 2 to the 60. this power added 1, 64 minus 1, 2 to the 64 minus 1, which is, okay. So I need somebody to help me to do this calculation. What is 2 to the 64 minus 1? Do me a favor, please. Plug into your calculator or your computer. Okay, thank you, Frank. So Frank says it's 1.8 10 to the 19th power. So let me write a little bit more clearly what is this number exactly is. It is 1, 8, 4, 4, 6, 7, 4, 4, 0, 7, 3, 709, 5, 5, 1, 6, 1, 5. So do you guys see how big this number is? So this is a thousands, this is a meaning, this is a binning, this is a training, this is 1,000 training, this is a million training, so it's 18 million training. Okay, that's how many grains the person want. And no wonder the emperor get very frustrated. So, you know, again, this is tyranny government. When the emperor gets frustrated, he has a hobby of beheading somebody who caused the frustration, right? So he beheaded him. Okay, so never fool anybody who can behead you, or never live in any country which has such a tyranny king. That's it for this question. Does anyone has any question how the calculation is done? Feel free to ask if you have any question. Okay, let me repeat the key idea. We just did a calculation for the first few steps. And we grab this calculation trick. Once we understand this trick, we understand the total grain is just 2 to the number of square, the index of the square, then minus 1. Okay. So then we give the answer without calculating for the last entry, which is just 2 to the 64 minus 1. Okay, that's it. That's the ancient story about tyranny. So let's look at the last question we have. Bacteria growth. Okay. So first of all, I want to give you 5 minutes to try this question. Before you try it, I need to let you guys watch another video about bacteria growth. Remember, bacteria growth is very similar with the previous question. Give me a minute, let's find me. Okay, everybody can see my screen, right? You must pay attention because this video is very short, very, very short. only 16 seconds, okay? Okay, get ready to watch this video.
Bacteria reproduce very simply and rapidly by doubling their contents and splitting in two. Just one bacterium, dividing every 20 minutes, could produce nearly 5,000 billion bacteria in one day.
Do you guys see the video? Okay, let's watch it again.
Bacteria reproduce very simply and rapidly by doubling their contents and splitting in two. Just one bacterium, dividing every 20 minutes, could produce nearly 5,000 billion bacteria in one day.
Okay. So let's go back. Oh, another video is up. Okay. So 5 minutes to work on example 4. Feel free to ask me any question. Okay, let's come back to work this question together. Again, this is a very funny question. To make this question more funny, the author of the question also made a illustration of bacteria. I mean, in my eyes, this looks more like a kind of squid, some kind of ocean animal, rather than octopus, or rather than bacteria. How do you guys feel? Do you guys feel this is a bacteria, or more like a octopus? I'm asking you guys a question. Do you guys feel this is more of an octopus or bacteria? Okay.
Bacteria.
Okay, so I know I'm the weird person in this class. Okay, so assume this is a bacterial. A biologist put this bacteria in a bottle at noon. At noon means 12 p.m. The bug population doubles every minute. An hour later, at 1 p.m., the bottle is full of bugs. And we have bacterial disaster in our hands. Because the bacteria is full of the bottle, we have to dump it. Okay, so very similar with the grains problem. The key information here is doubles every minute. The bag every minute, okay? So each minute you are times 2 to the original population. Bacteria can just split itself to reproduce. Unlike any kind of animals, bacteria do not need sex to reproduce. They just split itself. That's why you have one bacterial, which give you 2 bacteria in the next moment. Okay. So we do not calculate this right now. So let's calculate the first column first. Third row, you have 2 to the 2. Notice that again, very similar pattern appears. For each time you are having a 2 to the power, or 2 to the what power, it's same with a minute it elapsed, right? So in other words, 1 is just 2 to the 0. After the first minute elapsed, it has 2 to the 1. Second minute is elapsed, you have 2 to the 2. After 58 minutes elapsed, you have 2 to the 58. After 59 minutes elapsed, you have 2 to the 59. After 60 minutes elapsed, you have 2 to the 60. That's it. And here's the issue. 1 hour later or 60 minutes later, the bottle is full. By saying full, we have 2 to the 60 bacteria. We want to see what's the fraction of the bottle full. So let's go backwards. The previous minute, you have 1/2 full, right? Because each time you double. So each time you are times 1/2 to the previous. The minute before the previous minute, again, you times 1/2, which give you like a quarter. So what do we have here? So each time we have 2 to the 2 power, 2 to the 1 power. We have a fraction, right? This fraction, the denominator is constantly increasing. 2 to the 1, 2 to the 2. Okay. How big the power is, it's just how far this minute is from the final 60 minutes. 59 minutes is just 1 minute away. That's why we have 2 to the 1 power. 58 minutes is 2 minutes away from the 60. So you have 2 to the 2 power. Okay. How about the second minute? Can anybody have a brave guess? What is the power here?
2 to the 58.
Very good. You are right. Because we are 58 minutes away from the 60 minutes. Okay. The first. How about the second minute? So we are 59 minutes away. How about the beginning? We are 60 minutes away from the ending. That's it. So we calculate a few basic ones, then we infer the pattern. Okay. So those are the inferred values. We have not really done any kind of calculation. We just calculate a few basic ones. We guess it must be true. Does anyone has any question on this one? Okay, so we done all the calculation already. So leftover job is just fill in the answer. How many bacteria are there in the bottle at 1 hour? We calculate it is 2 to the 60. When was the bottle half full? Half full is just half. When the fraction is half, right? So it is 12:59. Okay, just look at the table. Find this is when it's half full. When was the table 1/8 full? So here's 1/4 full. So it must be the minute before this 1/4 full. You have 1/8 full, right? So should it be the minute before 12:58, 12:57. That's it. Okay. So that's for the first 3 questions. All sounds easy. Then here comes the funny one. Bacteria can develop their civilization and their technology. So, okay. So let me talk with you. You guys see me? Me, a mammal, right? A primate. So, do you guys know how old is our universe?
No.
Okay, so our universe is according to modern physics, around 14 billion years old. At the beginning of our universe, there was some kind of singularity. Then everything exploded from this singularity. Okay, so this is what modern physics said. 14 billion years ago, there was a big bang. The singularity exploded. Okay, at the beginning of the universe, we have some small atoms, such as hydrogen. Then gradually the hydrogen merges with each other. We have what is the second element in the periodical table? Helium, right? What is the second element on the periodical table? Second. Anyone speak out, please? Okay, so long story, I believe it's helium. So long story short, we have small atoms gradually merge into bigger atoms. And oxygen is pretty much much bigger atoms. Then those atoms merge with each other, we have molecules. Then those molecules merge with each other. we have like something like protein, DNA, that kind of stuff. Then those protein or other big molecules, for some reason, very small chance happened. They merge with each other. And we have the first bacteria in this universe. Then those bacteria merge with each other. You have some more complex organism. So with human beings, our origin is also a bacteria. Those bacteria merge with each other. So if you look at me, I'm kind of the descendant of those bacteria. So I just persuaded you that bacteria can also develop civilization. Okay? Any different opinion? Okay, thank you, Frank, for sharing. Frank said that we have more bacteria cells than human cells. That's correct. Thank you for sharing. Anybody want to add to that? Okay, so let's go back to the bacteria question. So bacteria have this space program, the NASA of bacteria. They send a little bacterial spaceship. They will discover 3 more bottles. And working quickly, they initiate a mass migration by packing bacteria into the spaceship and send them into new bottles. They successfully distributed population evenly among the 4 bottles, just in time to avert the disaster. Now they're in the 4 bottles. However, they are also reproducing with themselves. Okay, so for the, imagine this is the bottle they migrated to. So this is the original bottle. So original bottle is almost full, and they migrate to a quarter of it, migrate to each of them. Okay, just imagine this is a quarter. So how much time do they have left? Remember that bacteria keep doubling itself every minute. It's eating, drinking, reproducing itself every minute. Okay, does any people figure out the answer? Hi, Elizabeth, would you please elaborate why you think 102 would be the answer? Hi, Elizabeth.
Yeah, because at 1 they will have like a full bottle. At 101 they will have 2 full bottles, and at 102 they will have all of the bottles filled.
Great. I think you got it. Okay, so let me elaborate rephrase what Elizabeth has said. So at this time, each of the 4 bottles have a quarter full, right? Remember they are doubling itself. So the next minute is this a quarter times 2. Every bottle has 1/2 full, right? Then 1 minute later, the previous 1/2 also double. So you have 100% full. Okay, if we write it in percentage, it will be like this. At 1 o'clock, you have 25%. Next minute, you double, 50% full. The last minute, 100% full. So given such a space migration program they have, they only extend the civilization by 2 minutes. We should not blame. Do you guys realize what should we blame? We should blame their speed of reproduction. They're reproducing too fast. They're doubling themselves every minute. Okay, that's it for this question. Anyone has any question about this one? Okay, so if nobody has any question, let me take the attendance. Okay, I'm done with attendance. Stay here if you have any question. Otherwise, please feel free to go.
Thank you.
Bye.
Thanks.
Thank you. Have a good night.
You too. Bye bye. Hey, Yash. Hello, Yash. Are you there? Okay, Kitties, can I see you?
Hi.
Hi, nice to meet you. Nice to see you. Okay. So you wanted to make up those mistakes you did in the exam 1. Would you please share your screen so that I can give you some guidance on how you should navigate? You can share your screen.
Can you see it?
Yes, I can. So go to your MyMathLab.
Oh, yeah.
Yeah. No rush, take your time, please. Go to your MyMathLab.
Yeah, I always use this. So.
Oh, you can bookmark it, by the way. So next time to be easier. You can build a folder and bookmark everything you have.
So the thing is, I didn't do the exam like 2 times on that day. I did it like 1 time because I just couldn't do it. So this is the second one that I did like the night you told me to not do it. You know, Sunday night I did the exam.
Okay, so can you find the original exam?
No, that's like what I'm saying. I couldn't find it.
Okay. Okay, so how about this? You just do your makeup based on your second version, okay?
Oh, like the hair?
Yeah, so you did it again the night I told you not to do it. So you can just write all the mistakes in your second.
I wasn't able to click review.
Yes.
And actually, I have a question about the questions in here also.
Okay, show me, please.
Yeah, so this one, the first one. It's kind of confusing to me because it say the even number between including 36 and 48. So, I just...
Yeah. So would you please show me the mistake which you can find?
Yeah, so they say this one's a mistake. The one that I did it. You cannot see my screen?
I can see your screen, but but I'm not very understanding about your question. So Can you find your previous mistake or not?
No, this is. I don't know.
Okay, so click on the review, exam 1 review.
Yeah, this is exam 1 review. Do you want me to do it again? So exam 1, and this is.
Yeah. Click on it.
Yeah, I did.
Why there's no reaction?
Here it comes.
Why there's no reaction? The page did not refresh.
And you can see like which question I did wrong, but I couldn't find it.
Okay, so would you please refresh your page or close all other unrelated page? You have so many pages, close all others. Yes, click on refresh.
I cannot even click that. So where should I click now?
Did you accept my request?
I did.
Okay. Grade book. Okay, so now you see your mistakes, right?
Yes.
Did it?
Yeah.
Yeah. So you can just make your exam 1, post exam 1 wrapper based on the mistakes you.
Yeah. So, but I'm just gonna tell you because the first that I did on the exam day was I got like 75,
Okay.
and this one's the second one I did on the Sunday.
Okay, no problem. As long as you let me know, there's no problem here.
And I have a question about the question that I did wrong on this point.
Okay, show me the question. Which one?
So the first one actually. So let's say the even number between and including 36 and 48. So what did I do wrong? I say 36, 38, 40, 42, 44, 46, 48. What did I do wrong on this? Let's say including, so I just include that 36 and 48. And all the numbers are even. Oh.
Okay.
So I asked 28. Oh my god, I just mistyped it.
Okay, that's it. So do you have other questions for me?
Yeah, let me check. I thought it was the right answer.
Okay, great. So do you have other questions?
Yes. Just 1 second. I'm sorry.
Take your time, please.
So this one. So what did I answer? What did I do wrong on this?
You see, your typing is 0, comma. It should be 0 dot. Do you see the typing here? You type a comma, which is should be 0.79, not 0.79.
Thank you.
Okay, great. So every time you see a mistake, click on the red button here, so you can see the details.
Yeah. Thank you.
Okay, you're welcome. Anything else I can help you today?
No, I'm gonna do that. Right. So wait, can I get the point back, or
I'm sorry, what would you say?
can I, like, if I did all question right, can I get the point back or no?
You can get the points for the post exam 1 wrappers, which is 20 points.
But
Yeah, yes. So that post exam 1 wrappers and pre exam 1 wrappers, they are in the exam section, so they are kind of part of the exam grades. So that will also help you to improve your overall exam grade. Okay. Great. Anything else I can help you?
no, that's it.
Okay, great. So thank you for talking with me today. So I hope you have a great night. Bye-bye.